Hey, hello and welcome to today's GFG problem. The day hope you're doing well. So let's say today's problem, count distinct elements in every window. Okay, so what the problem is saying is we'll be given an array, okay, and we'll be given a k. So what we want to do is we want to find out the distinct elements, okay, in the window size k. For example, here since k is 4, right? So in this window size of 4, right? Or window size in this window size, right? Of 4, that is 4 elements. How many distinct elements are there? So it is 1, 2, and 3. Okay. So 1 is repeating, but we are going to, since it is asking distinct, right? So we are going to consider only ones. So there are 3 elements. So there are 3 elements which are distinct, right? There are 3 elements which are distinct in this window. Then the next window of size 4 is this particular, right? Till from starting from 2 to 4. So what are the distinct elements here? It is 4, right? It is 4 because 1, 2, 3, and 4, right? Again, we have to slide further. Okay, slide further, and we have to consider the uh, window from starting from 1 and ending at 2. So what are the distinct elements here? Again, 4, 1, 2, 3, 4, right? 1, 2, 3, 3 and 4, right? And what is the next again? Next one is the which is the last one starting from 3 and ending at 3. Again, the distinct elements here are 3, right? Because 3 is repeating, right? 3 is repeating once, okay, and 4 and 2. So that is why there are 3. So what we want to do is we want in each window of size k, in which window of size k we want to find out the distinct elements and return them. So what are those distinct elements? Those are 1, 3, 4, 4, and 3. These are the distinct elements, right? These are the distinct elements. So that's what the ask is. Okay, now let's see. Now let's go to the approach, how we're going to solve this problem. Okay, before going to the approach, I'll just request you to please subscribe to the channel, like the video. I'll try to make it very easy for you. Okay, so let's first see the naive approach. Okay, so what will be the naive approach? What we'll do is we will take a for loop I equal to 0 to n, right? And the another for loop will be starting from j equal to I. Okay, and it will go till less than k plus I, k plus I. Okay, I'll explain this, and then plus j. So this for loop will make sure to iterate the elements of size k, of window size k, to iterate the elements of window size k. For example, if I is starting from here, right? I is starting from here. J also will be starting from here. And since this is an inner loop, this will traverse till k plus I. What is k plus I? K is 4, right? K is 4 and I is 0. So k plus I, which is 4, right? Which is 4. So should be less than should be less than k plus I. So which is j should be less than 4. So 0, 1, 2, 3, and 4. Since it is saying that j should be less than 4, so it will iterate till these elements. So what I'm trying to say is this inner loop, right? This inner for loop will iterate the elements of window size k, which is what we want. And what we're going to do in each iteration, right? We're going to take a set, okay, of type of integer, right? This is a set, and we'll add the elements, right? Set dot add arr of j, arr of j. Okay, so this is a start for loop and end for loop. And whatever the size, right? We'll have a result list, right? Result list. We are going to add result dot add set dot size. What is the size? After this for loop ends, we'll have the set of distinct elements. We'll have the distinct elements, okay, in the particular window. Okay, so we're just going to set dot size. We're going to do. We're going to add in the result, right? So that's what this naive approach will be. But here, what will be the time complexity? It is going to be O of n square. How? Because there are two for loops, right? And hence the time complexity, it is going to be O of n square. Now we have to think of something better. So let's see how we can solve this problem. Okay, let me erase this. So since we have been asked, right, to have distinct elements, okay, to have distinct elements in the window of size k. So what we're going to do is we are going to solve this problem using sliding window approach. Okay, so let's quickly see how this sliding window, what the window approach is. So we are going to take 2 pointers. Okay, one will be window end, okay, which we are going to use to iterate all the elements, and one will be window start. Window start, initially window start and window end will be starting from zeroth location. Okay. And what we're going to do also, we're going to take a map. Okay. Let's take a map over here. Okay. So let's say we have this key and value pair. Okay. So map will be, the key will be the elements and the value will be the frequency of that element in that particular window. So simple. We are going to keep on iterating. Okay. Till WE minus WS plus 1 is less than K. Okay. So this is what I am trying to tell here is we'll keep on inserting elements till till window size K. Till window size K. What is that window size? Which is this four elements. So let's quickly see. So WE, right? So 1. 1 is not there. So we're going to insert 1 and we're going to increment the frequency. Then we are going to again increment WE. 2, we are going to check in the map. We're going to insert in the map. Since it is not there, we are going to add frequencies 1. Then we're going to increment WE. Okay. WE again. So this time it is 1. 1 is already there. So we are going to update the frequency of 1. Right. So we are going to go till this. So what is WE now? WE is 2. Right. WE is 2. WS is 0. So 2 minus 0. 2, which is 2. Which is 2 plus 1. Okay. Which is still less than. Which is still less than which is still less than K. Now what are we going to do? We are going to update our WE. W now points at 3. So again, we're going to check here. WE is 3, 0, 1, 2, 3 minus WS is 0 plus 1. Okay, now it violates, right? It is not less than K anymore. It is equal to K. So what we're going to do? We are anyways going to ingest. We are anyways going to ingest this 3 into this map. Just be with me, you'll understand. You'll understand. So we are going to put the frequency as 1. Okay, we are going to put the frequency as 1. And now at the same time, now since we have now reached the window size of K, right? WE minus WS. What is WE? W is 3, WS is 0, right? Plus 1, which gives us 4. So we have reached the window size and we have captured the elements in the map of the window size 4 of the first window. So simply what we are going to do, we are going to take a result. Okay, this is a list and we are going to add whatever the size of this map. So what is the size of map? Since there are 3 elements, the size will be 3. So we'll add 3. Okay, now since we have also reached this particular window, right? Now we want to iterate the next window, which will start from 2 and end at 4. So what we want to do is we want to remove this particular element or at least the frequency. Okay, we want to remove or decrement the frequency of this particular window start, right? Because now the next window will be starting from 2, right? So we want to decrement the value. Okay, we want to decrement this particular value from our map. Okay, so what are we going to do? So whatever is the WS, right? So whatever is the WS, which is 1, okay, we are going to decrement the frequency from 2 to 1. If it was only if the frequency was only 1, then we would have removed this one element. Since the frequency is 2, okay, we are just going to decrement. Okay, now we have done that, and also we are going to add. We're going to add. Yeah. So this is yeah. So now what are we going to do? Yeah. So we'll go to now our W is what? WE is 4 now. WE is 4. Okay, WE is 4 now. Now what are you going to do again? So this now what and also once we have processed the previous window, we are also going to increment our WS. We are also going to increment our WS. So WS will start from here now. Okay, WS and WE is here. Again, if you check what is WE? WE is 4 minus WS is 1. Okay, WS is 1 plus 1. Okay, plus 1, which is less than K. So again, we have got a window now. We have got a window. Okay, we have got a next window. Now what are we going to do? We are going to ingest 4 and we are going to increment the frequency as 1. Now again, since we have reached the second window, we are going to take the size. We are going to take the size of the window, which is 4, right? And also we are going to upgrade our WS. Now WS points here. WS points here now. Okay, at 1, right? And WE will be updated, will point to the next. Again, it is going to repeat the same. Now we have got another window. Okay, so what we are going to do? We are going to add this 2 into this map. Okay, into this map. We are going to add this 2 into this map. So which is what? Now WS starts here and yeah. So we are going to do what? We are going to add this, right? uh, 2, right? WE. We are going to add WE into this map. Now, also what we want to do along with this, we are going to take the size, whatever the size now. What is the size? It is 4, right? So we're going to ingest 4. The size of the elements in the map is 4. And we'll also increment a WS. Since we want our next window, which is that next window, it is this WS, right? Right. Yes. So we have done this, and again this 3, right? This 3. Now WE will also be updated now, and we're going to ingest into 3. We are going to ingest 3 into this map, and we'll update our frequency, right? We'll update our frequency. Again, WE minus WS will each time now. Only first window it takes time. The next time, the next window, like with each element, you reach the window size, right? You reach the window size, and and um okay, you reach the window size, and then at each element you have to remove WS, the element at WS, and you have to add the new element into this map. So in this way, this is the intuition to solve the problem. Okay, now let's go and code. I think you'll understand better with the code. Okay, so just one request before go to the code, to please subscribe to the channel, like the video. Okay, let me first reset this. Okay, I'd solve this. Let us solve from scratch. Okay, now what are you going to do? Let's take 2 pointers, WE and WS. Okay, WS. Then we're going to take what? The result list, right? So first I'll show the Java code followed by C++, new array list. Okay, then we're going to take a map to keep track of distinct elements, map equal to new hash map. Okay, then int, sorry. So no need to take WE separately. We'll take, since we are going to take in the follow, WE equal to 0, WE less than ir dot length plus I. Now what are we going to check? If WE minus WS plus 1. Okay, if it is less than K, that means this is for the first window. If it is like the window size is not reached yet, so we'll keep on adding the elements, right? Map dot put arr of WS, sorry, WE, arr of WE, and we want to check if the element is already present. If the element at arr of WE, if it is already present, or if it is not present, then return 0. This get out default. If the element is not present, it will return 0. And if the element is there, it will return the frequency of the element. And we just want to add 1 to the frequency of the element and put the element again into the map. Okay. So this, okay. So, and for example, now this condition was for the window size less than K, right? For the window size less than K. Now, once we have reached the window size, okay, once we have reached the window size, we want to add the new element. Okay, the last element, for example, right? For example, if this was a window 1, 2, 1, 3, now, and K is 4. So for example, if WE was here and WS was here, so what is WE? W is 3, minus WS is 0, plus 1 we were checking, right? Less than K. Now less than K. Now K is 4. Now this is also 4. Okay, which is not less than, which is equal to. So but we also want to add this element, right? We also want to add this element. We want to consider this element into the map, right? And hence we are doing this in the else part. Once it is done, now what we want to do? We want to add the size of the distinct elements, right? Wherein the map will give the size of the distinct elements, okay? The number of distinct elements, okay? So we have captured that. Now what do you want to do? Since, for example, this 1, 2, 1, 3, right? And what is the next element? 4. Now so this was the first window, right? Now the next window is this, starting from this. So what we want to do is, we want to remove this element, okay? Or decrement the frequency of this element from the map, and okay, and we want to update increment at WS window start, because this window will be starting from here, right? Okay, but we want to remove the previous element, okay, in order to have the distinct elements, the size of distinct element in this particular window. We want to remove this particular. Uh, okay, so that's what we're going to do now. If map dot get arr of WS, if it is still there, okay, If the element is there, okay, so what are we going to do? What are we going to do? We are going to again check if arr of ws, if the frequency was 1 only in the map, then just simply remove that element. Remove arr of ws. Just simply remove the element. If the frequency was more than 1, right, then we want to decrement the frequency. Map dot put arr of ws, map dot or default get or default arr of ws, or maybe just maybe no need to use get or default, right? Because we know that the arrow ws is present already. So whatever the frequency, decrement the frequency and put the frequency of that element again into the map. So we have done here. Now simply we also want to update our the next window, right? So we're going to increment our window start. Okay, and this is it. This is it. And finally, what we're going to do? We're going to return result. Okay, result will have all the distinct elements from all the window size, from all the window size of k. So let's compile. Okay, something wrong. Variable I, by habit use variable I. Hey, so it's compiled successfully. Let's submit it. Also, let's quickly see what is the time complexity. The time complexity, it is going to be O of n, because there's only one for loop, right? There's only one for loop. Okay, and we are using sliding window technique. So the time complexity is O of n only. In the naive approach, we saw it was O of n square. And what is the space complexity? We can say it is O of k. Okay, O of k. Yeah, we can say, or maybe yes, so extra space we are definitely taking here with the map, right? Extra space we are definitely taking. Okay, thanks for watching. I hope you got the solution. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. Okay, so here's the C++ code. Here's a map. Here's a resultant vector, and here's a again window, right? The for loop, right? And here what we are doing, we are keeping on adding the element into the map. And once, for example, if we reach the window size, it's bit different than what we have implemented in Java. Okay, if it is if the window size is reached, then add the distinct element size into the result. Okay, if it is one, the arrow of right, we want to remove the previous window start element, right? So we are doing that. If it is a frequency is one, then we are removing that element, and if the frequency is more than one, then we are decrementing the frequency of that particular element. And finally, we are updating our window start, and finally we are returning the result. So thanks for watching. I'll add the code in the description section. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.